Hi everyone, in this video I am going to solve O-Levels Additional Mathematics Paper 1 in a session October-November 2024 Paper 1-3. So let's start with the first question. Question number 1, Part A, find the coordinates of the stationary point on the curve y equals to this. Okay, so for the coordinates of the stationary points, for stationary points, basically we have to find y prime and put this equals to 0 and solve for the x and the y coordinates. So first let me solve for y. What is y over here? So we can say this is x square, x times x times minus 4x plus 3 times x and minus 3 times 4 is 12. So y is x square minus x and minus 12. This is my function y. Let me solve for y prime, which is dy over dx, the derivative of y with respect to x. So 2x minus 1. This is the derivative. X square derivative is 2x, x derivative is 1, so it's minus 1, and minus 12 derivative is 0. Alright, now for stationary points, we have to put the first derivative y prime equals to 0. Okay, so we have 2x minus 1, this would be equals to 0, 2x is equals to 1, shifting the 1 on the other side becomes plus 1, and x would be equals to 1 by 2. Now we have the x coordinate of the stationary point. Now let me solve for the y coordinate. So for the y coordinate, just plug the value over here. So y coordinate would be x values 1 by 2, its whole square, minus x values 1 by 2 and minus 12. This is 1 by 4 minus 1 by 12 minus 12. Simplify. 1 by 4 minus 1 by 12 and minus 12. That is minus 70. Wait a minute. This is 1 by 2, not 1 by 12. 1 by 4 minus 1 by 2 and minus 12. Minus 49 by 4. That is the y component. So we can say the coordinates of the stationary points are xy coordinates. The x coordinate is 1 by 2 and the y coordinate is minus 49 by 4. Now for part B, on the axis, sketch the graph of this absolute function stating the intercepts with axis. Alright, so first we have to state the x and the y intercept. So it's an absolute value function. Alright, and we can say the x intercepts. We have x is equals to negative 3 and x is equals to 4. Minus 3 and 4, these are the two x-intercepts. Let me work for the y-intercept. For y-intercept, we have to put x equals to 0, so y would be equals to 3 and minus 4, absolute. So y would be equals to absolute of negative 12, so y-intercept is positive of 12. 12 is the y-intercept. Alright, so let me do this. 1, 2, 3, 4. Okay, we can say this is 4, 8 and 12. This is the y-intercept. And for the x-axis, we can say this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4 and minus 5. Alright, so the x-intercepts are 4 and negative 3. 1, 2, 1, 2, 3 and 4, and minus 1, minus 2 and minus 3. And it should be in the positive region because this is the absolute, right? This is the y-intercept. The x-intercept. The absolute, this is the x-intercept. We can say for the absolute, and it passes through the y-intercept. That would be the shape of the sketch. Now for part C, given that k is greater than 0, write down the values of k for which the equation has exactly two distinct real roots. Two distinct real roots, all right? Okay, so this is the equation we have before we have y equals to this function. Now if we compare, we will get y equals to some k, right? And this k should be greater than 0. This is given. This is the condition. We have to write down the values of k when this equation is has two real roots. All right, so what are the values of k? Okay, so as we can see, this is the same function, so it has a stationary point. The stationary points are basically also called turning points, right? So we have the stationary points, or we can say the turning points, turning point of the curve, which is 1 by 2 and minus 49 over 4. Since y has absolute, so for absolute of y, we have 1 by 2 and 49 by 4. Y component is also positive. So the turning point, you can say x value is 1 by 2. Let's say this would be the turning point of the curve. This is a turning point of the curve. So it has a coordinates 1 by 2 and 49 by 4. These are the turning points, right? Okay, so for the turning point, it has two roots. If you can see, look at the curve now. Okay, if you fix this point, this line, y equals to, let's say this is y equals to 2 line, right? So it has four solutions, four distinct real roots. Again, 4, 4, 4. You have 4, it cuts the curve at 4 points. So let's say this would be the turning point of the curve. So when you draw this straight line, it has two solutions. It cuts the curve at 2 points. So when the value of y is more than the turning point of the y coordinate, we have only two real roots, right? So we can say that when the y is greater than 49 by 4, or we can say the k value is greater than 49 by 4, because y is basically equals to k. So when the k value is more than the y coordinates turning point, we have two real distinct roots. Otherwise we have 4. Question number 2, on the axis, sketch the graph of this function for minus 360 to plus 360, stating the intercepts with the x-axis. All right, we have to state the intercepts as well. Okay, so negative 360, it is in degrees. My calculator is in radians. It is in degrees now. Let me check for all these values, what are the solutions, right? So first we have to find out the intercepts, the x-intercepts and the y-intercepts. All right. Or if I can say 1, 2, 3, 4, 5. So this would be minus 2, minus 4, minus 6, and minus 8, and then 10. So this value is 2, 4, 6, and 8. Okay, so let's check all these values. When x is minus 360, minus 180, 0, 180, and 360. Okay, 4 plus 5 sine of theta by 2. Sine of minus 360 by 2. This value is 4. Positive 4. Okay, let me check at 180. Minus 180. This is negative 1. In the middle, negative 1. Let me check at 0. This is 4. At 0, it's 4. At 180, it's 9. At 180, it's 9 at up this point in the middle. At 360, this is 4. Okay, so 360 is again 4. So that would be the sketch. With the help of calculator, we can easily guess. It's a sinusoidal curve, you can see. Wait. Okay, so we have to move up after this as well. Yeah, that's the shape of this sinusoidal function. Question number 3, find the values of k for which the equation has no real roots. When no real roots, it means the discriminant, which is b square minus 4ac. This should be less than 0. It has no real roots. Let me see the discriminant. 4x square minus k minus 4kx plus 2 equals to 0. I just shifted these two terms on the left side of the equality and switching the signs. 4x square minus 4k is a coefficient of x and the constant term is 2 minus k equals to 0, right? So we can say the a term is 4, the coefficient of x square, b term is minus 4k, the coefficient of x, and the constant term is 2 minus k. Alright, let me solve the discriminant, which is b square minus 4ac. So the b term is 4k, its square, minus 4 times the a term, and the c term is 2 minus k. Let me simplify. For no real roots, it should be less than 0. All right, so simplify this. 4 square is 16, k square minus 16 into 2 minus k. So this is 16 k square minus 16 times 2 would be 32. 32 and plus 16k. So this is 16k square plus 16k minus 32. Okay, let me divide throughout the equation by 16. 32 divided by 16 is 2. So this is k square plus k and minus 2. Okay, that is the equation. So let me simplify. 1 times 2 is 2 and bring the midterm with 2 minus 1. So k square plus 2k minus k minus 2. This is k is common. We are left with k plus 2 minus 1 is common, k plus 2. Factors are k minus 1 and k plus 2. So we can say from here the k value is 1 and the k value is negative 2. All right, so where is this term? This is the quadratic equation. It should be less than 0. As you can see, the coefficient of k square is positive. So if I can draw the parabola, its opening is upward since its coefficient is positive. So the opening is upward. So this is the shape of the parabola. As you can see, its opening is upward because k square coefficient is positive over here. Now the coefficients are, the zeros are 1 and minus 2. This is minus 2 and this value is 1. This is less than 0. This is less than 0. When this curve is less than 0, it is less than 0 when the k values between minus 2 and 1. So these are the values of k when it has no solution. So we can say when minus 2 is less than k is less than 1, the equation has no solution. All right. Question number 4, part A. Write the number as a single base 2 logarithm. All right, single base 2 logarithm. We have to write it down. All right, so we can write. Okay, so 3. This term is just 1. 3 times 1 is 3. So what 1 is equals to in log? Base 2 is basically equals to 1, right? So I can multiply this term with base 2 because this is just 1. 4 log base 2a minus log base 2 and b. Now we have to write this as a single base 2 logarithm. So these are the base 2. The next step is log 2 cube, shifting the coefficient to the power, plus log 2a to the power 4 minus log 2 and b. So this is log 2 8 plus log 2a4 minus log 2b. So this would be log 2 8 and a4. These are addition, so we are doing product 8a4, and this is in subtraction, so we can divide by b, right? So this is in sum of single log. Moving to part B, solve the equation log x equals to 4 log base x 10. Let me use change of base formula over here. You can say log x equals to 4. We can say log 10 over log x. To change of base formula, the base is 10, right? Cross multiplied, we have log x whole square equals to 4 log 10. Log base 10 is 1, like we already did when the base and this term is same. So log x whole square, this would be equals to 4. To solve for x, taking a square root on both sides, right? So here we have log x equals to 4 square is 2, right? This is plus minus 2. So we have two cases here. When log x base is 10, this is 2. When log base 10x is minus 2. Let me solve the first case. So changing the log into exponential. So x would be equals to 10 to the power 2. So x would be equals to 10 times 10 would be 100. And here log base 10x, this is equals to 1 by 2. Sorry, not this one. I'm really sorry for this. X is again equals to 10 to the power minus 2. So x would be equals to 1 over 10 to the power 2. So here x would be equals to 1 over 100. So we have two solutions. X is equals to 100 and x is equals to 1 over 100. Question number 5. A polynomial p is such that p of x equals to this, where a, b, c are integers. It is given that x plus 2 is a factor of the polynomial. So what the factor mean? Factor means p of negative 2 should be equals to 0, because when we solve x should be equals to negative 2. So p of negative 2 should be equals to 0. It means the factor, the remainder is 0. When p of x is divided by x plus 1, the remainder is 20. It means p of minus 1 should be equals to 20. Show that this equation. Okay, use the part. What is the first one? P of negative 2 should be equals to 0, because x plus 2 is a factor of this polynomial. Let me replace x with negative 2. A minus 2 whole cube plus b, x is minus 2 square, minus 19 into minus 2 plus c equals to 0. So this is negative 8a plus 4b, and plus 2 times of 19 would be 38. 38 plus c, this is equals to 0, right? Let's see the next one. So we have p of minus 1 should be equals to 20. So a minus 1 cube plus b minus 1 square minus 19 into minus 1 plus c equals to 20. So this is minus a plus b plus 19 plus c equals to 20. Okay, now we have to simplify and we have to find the equation in terms of a and b. Okay, so we can say subtract equation 1 and equation 2. This is my 1 and this is my 2. Alright, let me subtract the two equations. So minus 8a plus 4b plus 38 plus c, this is equals to 0. And we have minus a plus b plus 19 plus c equals to 20. So let us subtract. So into subtraction we have to change the signs: plus, minus, minus, minus and minus. So this plus minus is cancelled out. So minus 8 and plus 1 would be minus 7a. 4 and minus 1 would be plus 3b. And these two, 38 and 19. 38 minus 19 is 19. Positive 19. This is negative 20. All right. So minus 7a plus 3b equals to minus 20 and minus 19. So 20 plus 19 is 39. This is minus 39. Let me take negative sign common throughout the equation. So this is 7a minus 3b equals to 39. So it is proved. Now for the second part, it is also given that when p prime of x is divided by x plus 1, the remainder is 1. P of 1, the remainder is 1. Find the values of a, b and c. P prime of x is divided by x plus 1. So first take p prime of x. P of x we have given is ax cube plus bx square minus 19x plus c. What is p prime of x? 3ax square plus 2bx and minus 19. Okay, now p prime of x is divided by x minus 1. So it means p of 1 should be equals to 1. So p prime of 1, sorry. Just simplify, just replace x with 1. So this is 3a plus 2b minus 19 equals to 1. Just replacing x with 1. So the equation becomes 3a plus 2b equals to 1 plus 19, that is 20. 3a plus 2b equals to 20. All right. Let me name this equation 4 and this one would be equation 3. Now we have two equations. We can easily solve for a and b. All right. Okay, so we have 3 and 7, 2 and 3. So let me multiply the equation 1 with 2 and equation 3 by 2 and equation 4 by 3, the opposite coefficients basically. So we can say multiplying equation 3 by 2 and equation 4 by 3 and add. Right. So let's do a multiplication. Equation 3 by 2. So this equation is multiplying by 2. 7, it's 7. So 7 times 2 is 14. A. 2 times 3 is 6b. And 2 times of 39. 2 times 39 is 78. And that equation is with 3. 3 times 3 is 9a. 3 times 2 would be 6b. And 3 times 2 is 6 and 0. Add them up. This is cancelled out. Let me solve for a. 14 plus 9 is 23a. 23a, not 2a. 78 and 60. This is 138. 138. And divided by 23. A value is 6. A equals to 6. Okay, we got the A. Now plug the A into first equation 3 or 4 to solve for B. So 7, A value is 6 minus 3B, this is 39. Okay, 7 times 6 is 42. 42 minus 3B equals to 39. So 42 minus 39, shifting the 39 over here, this would be 3B. From 42 minus 39, this is 3. 3 equals to 3B. So cancel it out, 1 would be the B value. Right. Now plug A and B, 6 and 1 into my equation number 1. This equation. All right. A is equals to 6 and B is equals to 1. Put in equation 1. Minus 8A plus 4B plus C plus 38 equals to 0. Right. 8 times 6 would be 48 minus plus 4 plus 38 plus c, this is equals to 0, right? So minus 48 plus 4 and plus 38, this is minus 6 plus c equals to 0. So the c value would be equals to 6. So we have all the solutions. C is 6. A is also 6, you can see. And B is 1. So these are the three values of A, B, C. Question number 6. The table shows the variables x and y which are related by the equation this, where A and B are constants. Alright, number A, use the data to draw a straight line graph for L and Y against x square. L and Y against x square. Okay, so we have to make the column for x square and for L and Y. 1 square is 1, 1.5 square. Taking the square of all the terms. 1.5 square is 2.25. Okay, 2 square is 4. 2.5 square is 6.25. And 3 square is 9. Let me take ln of 14. ln 14 is 2.64, rounded to 2 decimal place. ln 33.3 is 3.51. 112. ln 112 4.72. 4.72. Now ln 532.8, 6.28, and the last is ln 3584, 8.18. Let me draw a straight line graph. Okay, so x is 1, y is 2.64. All right, so these are the x values, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. This is my x square. 1, 2, 3, 4, 5, 6, 7, 8, and 9. When x is 1, y is ln y is 2.64. Okay, this is 2. 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.64 for x is 1. This is x is 1. Okay, x is 2.25. 2.25. So 2.2, 2.4, 2.6, 2.8, and 2.10 would be 3. 2.25. 2.2 is this and 2.25 is in the middle. And y is 3.51. Okay, this is 3.1, 2, 3, 4, 5, and 3.51, corresponding to this line in the middle. Okay, for 4, 4.72. Okay, this is a line 4. Here we have 4, 4.1, 2, 3, 4, 5, 6, 7, 4.72. For 6.25, 6.28, 6.25, 6.2 and 6.25 is in the middle. Okay, this is, let me go to 6. This is 6.28, 6.1, 6.2, 6.28, and from here we have 6.25, this point, right? Corresponding to 9, it is 8.81. 9 is this straight line at the end, right? You can see 8.81. This is 8, 8.18. Draw the line. Yeah, it must be a straight one. This is a straight line graph for ln y against x square. Now for part B, use your graph to estimate the values of A and B. Give your answer correct to one significant figure. So we have y equals to A, B, x square, right? Now let me take ln on both sides. So ln y would be equals to ln A, B, x square, right? This is ln y equals to, these are in the product, so we can add ln a plus ln b to the power x square. This is ln y equals to ln a plus x square ln b. We have to solve for a and b. This is a and this is b. All right, so that is the equation. Now it's a straight line equation. Let me rewrite ln y equals to ln b x square plus ln a. Compare this equation with y equals to mx plus c, right? So here m is the gradient and my c is the y-intercept. So when we have to work in xy, now we are working in x square and ln y. So my slope or the gradient is ln b and my y-intercept or the c value is ln a. All right, this is just for the understanding. Okay, so now my y-intercept, ln y-intercept basically, this value is my ln a. Let's see, we have to use our graph, right? So let's find out the intercept. Extend the line and find out the intercept. Yeah, the line is extended. Now find out the intercept, the y-intercept. This is 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, or in the middle 1.95. So ln of a is basically 1.95. And what is a? E to the power 1.95. 1.95, yes. Let me solve for a. E to the power 1.95. 7.02. 7.03, or a is 7.03. We have to find the answer for one significant figure. So here a value is just 7 for one significant figures. So we got the a. Let me solve for b as well. Okay, now the next is the gradient. Yes, the next thing is my gradient. We can say the gradient or the slope is rise over 1, and in this case the gradient is ln b. Look at the graph. From the y-intercept, how much we have to rise. So if we start from here, how much unit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, till this is the next point, so we are working with this one. So how much is the rise? We have rise 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, 6 unit, and 7 unit in the middle. And here we have to run just 1 unit. You can see just 1 unit we have to run. So the rise is 7 units and the run is 1 unit. So from 1.95, this point is 2.64. How much is the difference? 2.64 minus 1.95, 0.7. The difference is 0.7 unit. So the rise is 0.7 and the run is just 1 unit. So we can say this ln b is 0.7. and the b is e to the power 0.7, converting natural logs to exponential. So e to the power 0.7, this b value is 2.013. Up to one significant figure, the b value is just 2. A is 7 and b is 2. Now for part C, use your graph to estimate the value of x when y is 200. Give your answer correct to two significant figures. Okay, so we can say when y is 200, what is ln y? This implies what is ln of 200, because the graph is against ln y and x square. So we can say ln of 200 is 5.3 up to two significant figures, right? So this implies when ln y is equals to 5.3, what is my x? What is x square corresponding to that value? Let's see, use the graph, because in this question we have to use a graph. When ln y is to 5.3, okay, ln of y 5.1, 5.2, 5.3, we have to solve for x square. Here we have 5.3. All right, we have to work on x square. What is my x square? All right, so my x square is 4.2, 4.4, 4.6, 4.8, 4.8, 4.8, 4.9, 4.85 is better. Take in the middle. Yes, my x square is 4.85. X square is 4.85. So what is x? Square root of 4.85. So solve for x. Square root 4.85. This is 2.20. Up to two significant figure, x value is 2.2. This is the x value. Question number 7, part A. Given that y is this function, find dy by dx. It's a product rule. So dy over dx, the first function is x cube, the derivative of the second function, which is ln x, plus the second function is as it is, and the derivative of the first function, which is x cube. Let's simplify, which is x cube. Ln of x derivative is 1 over x, plus ln x is as it is, x cube derivative is 3x square. This x and this x is cancelled out, we have just square. So x square plus 3x square ln x. This is the derivative of the function y. Or we can write this down, d by dx of the function x cube ln x is x square plus 3x square ln x, right? Now for part B, hence find the integral, giving your answer in the form of ln a plus b, where a is an integer and b is a rational number in the form of p by q. B must be in the form of p by q. A can be integer, it can be positive or negative number. All right. So we hence find, means we have to use the first part. So in the first part, we have given d by dx of x cube ln x. This is x square plus 3x square ln x, right? Integration dx, integration dx, integration dx. All right. So dx is cancelled with dx, derivative is cancelled with integral. We are left with x cube ln x. We are not applying the limits right now, okay? This is x square is x cube over 3 plus 3x square ln x dx. Now apply the limits 1 to 2. 1 to 2, 3x square ln x dx. 1 to 2, 1 to 2, 1 to 2, 1 to 2. Applying the upper and the lower limits here. So from here, integral 1 to 2, 3x square ln x dx. This would be equals to this term shifting on the other side, x cube ln x minus x cube over 3, and the limits are from 1 to 2. Applying the upper limits first, which is 2 cube ln 2 minus 2 cube over 3. This is my upper limit. Subtract the lower limit is 1 cube ln 1 minus 1 cube over 3. ln of 1 is 0, I guess. Yeah, ln 1 is 0. This term is 0. So we can say this is 8 ln 2 minus 8 over 3. Negative times negative is positive 1 by 3. 1 by 3 minus 8 by 3 is minus 7 by 3, right? This would be ln 2 power 8 minus 7 by 3. 2 power 8 is 256. ln 256 minus 7 over 3. So now this is in the form of ln a plus b. A is an integer, which is 256, and b is a rational number, which is 7 by 3. Question number 8. A straight line y equals to 2x plus 1. This is a straight line. Intersects the curve, this curve, at a points a and b. Okay, so first let me find out points of intersection of line and the curve. All right, so y equals to 2x plus 1. Substitute the y over here. So this y would be 2x plus 1 plus x. Again, this y is 2x plus 1 plus 3x square equals to 15. All right, this is 2x plus 1 plus 2x square plus x plus 3x square minus 15 equals to 0. This is x square term, this is x square term, this is 5x square. X term is 2 and 1, which is 3x. 1 and minus 15 is minus 14 equals to 0. Right? Now let me simplify this and finding out the a and the b points. All right, so factorize, or 7 times 14 is 70. Factors of 70 to make 3. Let's apply a quadratic formula over here. It's better. A, B, and this C. X is equals to negative of B plus minus square root B square minus 4 times the A value times the C value divided by 2 times of the A value. So x is equals to negative 3 plus minus square root. This would be 4 times 5 times 14 plus 3 square is 9, 289, and 2 times 5 is 10. Square root of 289 is 17. So x would be equals to negative 3 plus minus 17 over 10. All right, negative 3 plus 17 over 10. X is equals to 7 by 5. And the other one is negative 3, negative 17 over 10 is negative 2. So x is equals to negative 2. So we have the 2x coordinates. Let me solve for the corresponding y values by plugging the x coordinates into the straight line. All right. So we have the equation for y, the straight line equation, y equals to 2x plus 1. Y equals to 2, the x is 7 over 5 plus 1, and y equals to 2, the x is minus 2 plus 1. Let me solve for the y. 2, okay, 7 by 5 times by 2 and plus 1. Here y is 19 over 5. 2 times minus 2 and plus 1 is negative 3. The y is negative 3. All right. So we can say that was the first step for the points of intersection of the line and the curve. So let's say the A coordinates are 7 by 5 and 19 over 5, and the B coordinates are -2 and -3, because in the question it is given that the straight line intersect the curve at the points A and B. So we have done with the points A and B. All right, the point C with the coordinates these are the coordinates of the point C, lies on the perpendicular bisector of AB. Find the exact value of K. Perpendicular bisector of AB. So we have the coordinates of AB, just we have to find the perpendicular bisector of AB. Let me do the remaining work on the separate sheet. Question 8A. Let me rewrite the coordinates of A and B, which is 7 by 5 and 19 by 5. And the B coordinates are -2, -3, yes. Okay, so these are the coordinates of A and B. So we have to find the perpendicular bisector of AB. So first we need the midpoint of AB and the slope of AB. So the midpoint of AB. So for the midpoint, we have to add the x components, which are 7 by 5 and -2, and divided by 2. And adding the y component, 19 by 5 and -3, and divided by 2. We will get the midpoints. Let me simplify. 7 by 5 -2 divided by 2, -3 over 10, -3 over 10. 19 by 5 -3 divided by 2 is 2 by 5. These are the coordinates of the midpoints. Now the next thing is we have to find out the slope or the gradient of AB, which is y2 minus y1, y2 minus y1 over x2 minus x1, x2 minus x1. Okay. This is -3 and -19 over 5 is equals to -34 over 5 whole divides -2 and -7 by 5, -17 over 5. 5 is cancelled, minus is cancelled, 34 over 17 is 2. 2 is the slope of AB. Now the slope of perpendicular bisector of AB is negative reciprocal. So the slope of the perpendicular line is always negative, and the reciprocal, so negative, the reciprocal of 2 is 1 by 2. Now let me find out the equation of perpendicular bisector. Equation of perpendicular bisector of AB. So that equation is y minus y naught equals to m into x minus x naught. So this is my x naught, this is my y naught, and this is my m. All right, just plug the values. Y minus y naught is 2 by 5. M values -1 by 2. And x minus x naught is 3 by 10. It's positive now. Okay, so this we have done with the perpendicular bisector of AB. This point C lies on it. Okay, so 21 over 10 and K. Okay, so we can say point C, which is 21 over 10 and K, lies on equation 1. Let's say the perpendicular bisector of AB is equation 1. This point lies on the equation 121 by 10 and K. So this is x component and this is a y component, and so let me solve for the y. The y is this K minus 2 by 5. We have to solve exact value of K. We have to solve in question part A. -1 by 2. X component is 21 over 10 and plus 3 over 10. Simplify. 21 plus 3 divided by 10, okay, times it by minus 1 by 2 minus 6 over 5. So k is minus 6 over 5, and shift this term on the other side, plus 2 by 5, and add 2 by 5 minus 4 by 5 is the k value. This is the exact value of k. Now for part B, the point D lies on the perpendicular bisector of AB such that its perpendicular distance from AB is twice that of point C from AB. Find the possible coordinates of D. Alright, so let us visualize this situation. Okay, so let us suppose this is XY plane. Alright. Okay, so let's say this is a line AB. This is line A and B. Here is the line which is perpendicular to AB, right? This is the line which is perpendicular to AB, or we can say the perpendicular bisector of AB. And here we have the midpoint. All right, now the point D lies on the perpendicular bisector of AB. So let's say the point D lies on the perpendicular bisector of AD such that its perpendicular distance from AB, point D perpendicular distance from AB, right, the perpendicular distance of D from AB is 2 times, and from part A we also come to know that C also lies on the perpendicular bisector. Let me recall, the point C lies on the perpendicular bisector, right? Okay, the perpendicular distance such that its perpendicular distance from AB is twice that of point C from AB, is 2 times of the distance of perpendicular distance of C from AB. So what I'm trying to say is the perpendicular distance of D from AB. So this is the perpendicular distance of D from AB, means D to M. The distance DM is 2 times of the distance CM, right? D lies on the perpendicular bisector of AB such that D perpendicular distance of D from AB. So the perpendicular distance of D from AB is basically DM, and this is 2 times of the perpendicular distance of C from AB, which is CM. Okay. Now let's say the coordinates ABC. The D coordinate is XY, and we have done with the M, the midpoint in part A, which is minus 3 over 10 and 2 by 5, and the C coordinates are 21 over 10 and K, and we got the K value which is minus 4 by 5. Okay, let me simplify this. So the distance, use the distance formula. Distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square and the whole square root. Okay, let me solve this. Okay, the distance of dm, this is d and this is m, right? So use the distance formula, square root of x2 minus x1 whole square, which is x. This is, let's say this is x2 and this is x1. x2 minus x1, so plus 3 over 10 whole square, plus y2 minus y1 whole square, which is y minus 2 by 5 whole square, and the square root. This is equals to 2 times the distance of these two, C and M. x2 minus x1, which is 21 over 10, and plus 3 over 10 whole square, plus, and the square root we have, and y2 minus y1 whole square, so minus 4 by 5 and minus 2 by 5 whole square. All right, so this is square root x plus 3 over 10 square plus y minus 2 by 5 square. This is equals to 2, and the square root We have 21 by 10 and 3 by 10. 21 plus 3 is 24 divided by 10, which is 12 by 5, and the square is 144 over 25. Plus, this is minus 4 and minus 2 would be minus 6, which is minus 6 by 5, and take its square, which is 36 over 25. Now denominators are same. 144 plus 36, 180 divided by 25. So square root of x plus 3 over 10 whole square plus y minus 2 by 5 whole square. This is 2. This is 36 over 5. Okay, in the square root, keep this as it is. 36 over 5. All right. So now let me square on both sides to get rid of the square root. Now squaring on both sides. Square of this side and the square of this side. So this square and square root is cancelled. This square and square root is cancelled, and we do the square of 2 as well. So we have x plus 3 over 10 whole square plus y minus 2 by 5 whole square. 2 square is 4, and we have 36 over 5. 36 times 4, 144 by 5. This is 144 divided by 5. All right. So what y value we are going to use? Since the point D lies on the perpendicular bisector of AB, so this y value we have to use as the perpendicular bisector of AB. That would be the y value, and we have done with the perpendicular bisector of AB from part A. This is my perpendicular bisector of AB. So this is a perpendicular bisector of AB. Let me rewrite it over here, which is y minus 2 by 5 equals to minus 1 by 2 into x plus 3 over 10. So we have to solve for y and substitute the value over here. All right. So here y is equals to minus 1 by 2x minus 1 by 2 times 3 over 10, and shifting this term on the other side becomes plus 2 by 5. Here y value is minus x over 2, and what is the constant? The constant term is minus 1 by 2 times 3 by 10. This is minus 3 over 20 and plus 2 by 5. Okay, add 2 by 5. This is 1 by 4. So y would be minus x by 2 and plus 1 by 4. Let me substitute this y value. So now we have x plus 3 over 10 whole square. Y value is minus x by 2 plus 1 by 4 minus 2 by 5, its whole square equals to 144 over 5. Let me solve for x here. This is x plus 3 over 10 whole square. This is minus x over 2, 1 by 4 and minus 2 by 5, minus 3 over 20 whole square equals to 144 over 5. Let me open the square. A plus b whole square, the first term square, and 2 times the first term times the second term. 2 times of 3 by 10, 3 by 5x, and the second term square. 3 square is 9 and 10 square is 100, plus this is when you take the negative sign common and take its square is just positive 1. First term square is x square over 4 plus 2ab. Okay, 2 into the first term is 1 by 2, into the second term is 3 over 20. This is just 3 by 20. 3 over 20x. 3 square is 9 and 20 square is 400. 144 over 5. Let me double check 20 square. Yes, that is 400. Now simplify the x square coefficient. 1 plus 1 by 4. 5 by 4 is a coefficient of x square, 5 over 4 x square. All right, the x term is this and this, 3 by 5 and 3 by 20. 3 by 5 plus 3 by 20, 3 by 4 x. These two are the constant term. 9 by 100 and 9 by 400. 9 over 80, and we can say 144 by 5. All right, and we have to subtract the answer is equals to this. Wait, let me simplify. 9 over 100 and 9 over 400, 9 over 80 plus 9 over 80 and subtract 144 over 5. This is equals to 0. I shifted this term on the other side. Minus 144 by 5 is minus 459 over 16. Let me simplify this further. This is 4 by 5 by 4 x square plus 3 by 4 x and minus 459 over 16. 459 over 16 equals to 0, right? So let me multiply this equation by 16 to get rid of this fraction. 4 times 4 is 16. 5 by 4 times by 16 is 20. So x square coefficient is 20. 3 by 4 times by 16, 12. And this 16 and 16 is cancelled, minus 459 equals to 0. All right, further simplification, this is a quadratic equation. So let me solve this by quadratic formula. And find out the roots. So the a value is 20, b value is 12, and the c value is minus 459. Apply the quadratic formula. X is equals to negative of the b value plus minus square root b square minus 4 times the a value times the c value. It's a square root and divided by 2 times of the a value. Let me simplify this further. X would be equals to negative of 12 plus minus, we have minus 4 times 20 times minus 459. Okay, and add 12 square and the square root of answer 192. And 2 times 2 is 4 and 0. So we have two solutions. X equals to minus 12 plus 192 by 40. And x is equals to minus 12 minus 192 over 40. Okay, so minus 12 plus 192 by 40 is 9 by 2. X is 9 by 2. Minus 12 minus 192 by 40, this is 51 over 10 with negative sign. So x is equals to minus 51 over 10. Okay, so these are the two x coordinates. We have to find the y coordinates as well by plugging the value into the perpendicular bisector of AB. So we have just done the y equation is this, right? Plug over here. Y is equals to minus x by 2 plus 1 by 4. So let me do this. Y equals to minus 1 over 2, x is 9 by 2 plus 1 by 4. And here y is equals to minus 1 by 2, x is minus 51 over 10 plus 1 by 4. So what is y? Okay, this is minus 1 by 2 into 9 by 2 plus 1 by 4 is negative 2. The other one is minus 1 by 2 times minus 51 over 10 and add 1 by 4, 14 over 5. Y is 14 over 5. All right. Now we can say the coordinates of D we have to find the possible coordinates of D, right? So we have two possible coordinates of D. The first one is x is 9 by 2 and y is minus 2, or x is minus 51 over 10 and the y is 14 by 5. So these are the two possible D coordinates. Question number 9. The diagram shows the trapezium OABC. O, A, B and C. This is a trapezium where OA is 4A, OC is C, CB is 2A. The point D lies on AB. D is the point which lies on the line AB, such that AD and DB, A to D and D to B, are in the ratio of 2 and 1. Okay, so 2 plus 1 would be 3 and the total ratio is 3. So A to D is 2 by 3 of AB and D to B is 1 by 3 of AB, because A to D and D to B are in the ratio of 2 and 1. So 2 ratio and 1 ratio, and the total is 3 of the total AB, right? Okay, the next part is the point X is the point of intersection of the lines OD and BAC. This is a point of intersection. All right, X is a point of intersection. It is given that AX, A to X, is lambda times AC. All right, and OX is mu times OD. Okay. All right, find in terms of A and C. Number 1, AB. A to B follows the path AO, OC, CB. Okay, AB is A to O, O to C, and then C to B. What is AO? Minus 4A plus C and plus 2A. So this is C minus 2A, which is AB. So this AB is C minus 2A. So this replace AB with C minus 2A, and this AB is also C minus 2A. Now for the next part B, OD. O to D follows the path of OA and AD. All right, OA plus AD. What is OA? OA is 4A and A to D is 2 by 3 of AB. This is 4A plus 2 by 3 of C minus 2A. This is 4A plus 2 by 3 of C minus 2 by 3 of 2A. Okay, so the C is 2 by 3C and the A is 4A and minus 4A over 3. Okay, let me simplify. 4 minus 4 by 3. 4 minus 4 by 3 is 8 by 3. 2 by 3C plus 8 by 3A. This is OD. All right. Now for part C, find OX in terms of AC and mu. O to X, okay, which is given mu times OD. Okay, OX is mu times of OD. We have mu times of OD is from part B is this, which is 2 by 3C plus 8 by 3A. Now for part D, find AX in terms of AC and mu. AX. Okay, A to X we have to find. Okay, AX is lambda AC. We have to find in terms of lambda, yeah. AX is lambda times AC. Now what is AC? A to C is A to O and O to C. Okay, this is lambda. AO plus OC. When we move from A to C is A to O, which is minus 4A, and O to C is just C. So lambda minus 4a plus c. So this is lambda c minus 4a. Now for part E, hence find the values of lambda and mu. All right. So which thing involve lambda and mu? So you can see ax involve lambda and ox involve mu. Okay, so this involves mu and this involves lambda. So we have to use this portion to get the value of lambdas and mu. Okay, so O to X, OA and AX. Let me write this down. OX is OA plus AX, OX, OA, AX. OX we got in part C. Okay, let me show you guys. We have OX and we have AX as well, and we have OA, which is 4A. Just substitute all the values. OX is equals to mu 8 over 3A plus 2 by 3C. OA is 4A plus AX is lambda times C minus 4A. Okay, so we have to find the values. So 8 over 3a with mu plus 2 by 3c with mu plus 4a plus c with lambda minus 4a with lambda. So now we have to compare the coefficients. Compare coefficients of let's say mu first. Okay, this is mu, and this is equals to, and not no mu on the other side. Yes, so we can say sorry, we have to solve for lambda and mu. So if we compare the coefficients of mu, we will get a and c, right? Not the mu and the lambda. So first compare the coefficients of a. Okay, a coefficients are 8 over 3 mu equals to 4 minus 4 lambda. This is a 8 over 3 mu. This is a coefficient and this is a coefficient, right? Now we have to the equation in lambda and mu. Compare the coefficients of c, a and c. C coefficient is 2 by 3 mu. On the other side we have just lambda. Yeah, this is a, this is c, this is a. Yes. Okay, so what is lambda and what is mu? So the lambda value, let's say this is my equation 1 and this is my equation 2. Lambda is 2 by 3 mu. So we can say put equation 1 and equation 2. So 8 over 3 mu equals to 4 minus 4, and the lambda is 2 by 3 mu. Simplify further. We have 8 over 3 mu equals to 4 minus 4 times 2 would be 8 over 3 mu. 8 over 3 mu, and this shifting on the other side, plus 8 over 3 mu equals to 4. 8 plus 8 is 16 over 3 mu equals to 4, and the mu value would be 4 times 3 over 16. 4 times 1 is 4, 4 times 4 is 16, and here the value of mu would be 3 by 4. Alright, so we have done with the mu. Now substitute this mu value into equation 1, because equation 1 is, we will get lambda. Put mu in equation 1. Lambda is 2 by 3 of mu, which is 3 by 4. 3 is cancelled with 3, 2 times 2 would be 4. So from here lambda is 1 by 2. So we have done with the lambda and the mu both values. Question number 10 part A, solve the equation for theta is between minus 180 to plus 180. Alright, so 7 times 2 is 14. If we factorize this, it's look like a quadratic in tangent theta. So 7 times 2 is 14. And And if we can say 7 minus 2, this would be 5. We can break the midterm 5 with 7 minus 2. So we have 7 tan square theta plus 7 tan theta minus 2 tan theta minus 2 equals to 0. Let's take 7 and tan theta common. We are left with tan theta plus 1. Let's take negative 2 common. Tan theta plus 1. Factors are same, right? So the factors are tan theta plus 1 and the other factor is 7 tan theta minus 2. Now put both factors separately equals to 0. We can say tan theta is plus 1 equals to 0 and 7 tan theta minus 2 equals to 0. From here tan theta would be equals to negative 1 and from here tan theta is equals to 2 shift on the other side and divided by 7, 2 by 7. So these are the two values for tan theta. Now let me solve for theta between 180 to plus 180. So theta would be equals to tangent inverse of 1. This is in degrees. My calculator is in degrees. Yes. Okay, so we have to solve for the positive. Now we can check tangent is negative in which quadrant by according to the cast rule. So if I can draw the cast rule, C, A, S and T. So tangent is positive in first and third. Second and fourth it is negative. So here we can say that tangent is negative in second and fourth quadrant. And here tangent is positive. So tangent is positive in first and third. Tangent is positive in first and third quadrant. Right. Let me use a separate sheet of paper for this. So first we can say theta is tangent inverse of 1, which is 45. Tangent inverse of 1 is 45 degrees. So the theta is 45 degrees. Now tangent is negative in second and fourth quadrant. Second quadrant, what is the operation for the second quadrant? Which is 180 degree minus this theta, 45 degree. Okay, from 180 subtract 45, 135 degree. So we can say theta is equals to 35 degrees. Okay, and it is also negative in the fourth quadrant. So fourth quadrant, the operation is theta is equals to 360 degree. We have to subtract 45 with this angle. Okay, 360 minus 45 is 315. Right. Let's look at the second case when tan theta is 2 by 3. Okay, so tan theta is equals to 2 by 7. Theta is tangent inverse of 2 by 7 in degrees. Tangent inverse 2 by 7, 15.9 degrees. Theta is 15.9 degrees. This is in the first quadrant. And it is also positive in the third quadrant. So for the third quadrant, we have the operation which is 180 plus this value. Theta is 180 degree plus this value. Okay, 180 plus answer, which is 195.9, 195.9 degrees. Now let's look at the domain. This is between minus 180 to plus 180 and we have the solutions. 135 degree. Okay, let me write down all the values of theta. Theta values are 135 degrees, 315 degrees, and 15.9 degrees and 195.9 degrees. Okay, so what values belongs to the domain? Minus 180 degree is less than equals to theta is less than equals to 180 degree. 135 is in the range of 180, not this one. This is in the range and not this one as well. So the positive values of theta are 135 degrees and 15.9 degrees. Okay, let's find out the negative values of theta. So in theta we have to subtract 180. We will get the negative values of theta. 135 subtract 180, which is minus 45 degrees, and 15.9 subtract 180, this is minus 164.1, minus 164.1 degrees, right? So the values of theta, if I arranged, theta values are minus 164.1 degrees, minus 45 degrees, 15.9 degrees, and 135 degrees. All these values belongs to the given domain of theta. Now for part B, solve this equation for phi is between 0 to 3 where phi is in radians. So first thing first, let me convert my calculator into radians. This is in radian mode now. Okay, now let me simplify this. So if I can say sine of 3 phi minus 1.5, this would be equals to shifting the 2 on the other side, it becomes positive, and dividing by 3. This is the equation in terms of sine. And according to the cast rule, sine is positive in first and second quadrant. All right. So let me simplify. 3 phi minus 1.5. This would be equals to sine inverse of 2 by 3. Okay, sine inverse 2 by 3. 0.73. This is 0.7297. If I did till 4 decimal place, 7297, yes. And this is a value for the first quadrant, and sine is also positive in the second quadrant as well. So what we have to do for the second quadrant, so for second quadrant the operation is pi minus this value. So pi minus answer 2.4118, 2.4118. All right, so let's solve for phi. Let me solve for the phi value. So 3 phi minus 1.5, this is 0.7297. What is phi? Phi is 0.7297. Add 1.5 and divided by 3. And also 3 phi equals to minus 1.5 equals to 2.4118. So phi is 2.4118 plus 1.5 divided by 3. So what are the values of phi? We have 0.7297 plus 1.5 divided by 3. This is 0.7432. Okay, the next value of phi is 2.4118 plus 1.5 divided by 3 is 1.3039. Okay, so these are the two values of phi to get all the desired angle which are between 0 to 3. Since angle is not just phi, it is 3 phi minus 1.5. So we have to add and subtract 2 pi, but we are not subtracting 2 pi because the range of this phi bit is positive 0 to 3, not the negative values. So that is why I'm just adding 2 pi. So adding 2 pi in this value and adding 2 pi in this value, and then we have to solve for phi. So let's do this. So we can say 3 phi minus 1.5. We have the two solutions, this and this. So in these two solutions, let add 2 pi. 0.7297 adding 2 pi is 7.01288. This is 7.01288, and the other solution is 2.4118 add 2 pi. This is 8.6949. 8.6949 when add to pi in. Okay, now let's solve for phi. So in these two values, we have to add 1.5 and divide it by 3. 7.01288, add 1.5 and divide it by 3 is 2.84, right? The other one is 8.6949, add 1.5 divided by 3. This value is more. This value is 3.39 means 3.40 after rounding, but the values are between 0 and 3, so 0.7, 1.3, 2.8. So these three values are between 0 and 3. So we can say the answer phi is 0.74, 1.30 and 2.84. So these are the three solutions. Question number 11, part A. The first three terms in an arithmetic progression are this. Find the sum of n term. Sn we have to find, giving your answer in the form of this, where k is in terms of n. Alright. So Sn is n by 2 into 2a plus n minus 1 into d. We have to solve for Sn. So Sn is n by 2 into 2 times of a is the first term, which is log base x3, plus n minus 1, and the common difference is the difference between these two terms, which is log base x81 minus log base x3. Okay, so Sn is n by 2. Okay, so this is log base x3 to the power 2 plus n minus 1. Let me solve for the d. So this is log base x, the difference, so 81 over 3. 81 by 3 is 27. So Sn is n by 2 log base x, 3 square is 9, plus n minus 1 log base x, 27. Okay, we need further simplification. Sn is n by 2 into log x9 plus n log x27 minus log x27. All right, so this would be n by 2 is outside, so let me solve these two logs. So we can say log x9 and 27, so 9 by 27 plus n log x27. What is 9 by 27, which is 1 by 3. So further simplification, Sn is n by 2. This is log x 1 by 3 plus n into log x 27. All right. So Sn is n by 2 log x3 to the power 1 minus 1, because we can shift the power, plus n square by 2 multiplying log x27 is a cube of 3. 3 cube is 27. We have to find the answer in terms of k log base x3. Okay, the base is x, but in terms of 3, and k is in terms of n, so these values are in terms of n. The base is x. All right, now we can say make log base x, and the argument of the log must be 3. So Sn is n by 2 minus 1 is over here, log x3 plus n square by 2. 3 is over here, the power comes before the log x3. So log x3 we have done. Let's take log x3 common. So Sn is minus n by 2 plus 3n square by 2, and we have log base x3. Okay, this is k in terms of n, and the sum is in the form of k log x3. All right, now for part B, the first three terms in the geometric progression are theta is between 0 to pi by 2. Find the values of theta for which this geometric progression has sum to infinity. Okay, the geometric progression has a sum to infinity when the common ratio is between 1 and -1. Let me solve for the common ratio. The second term over the first term, which is 3 tan square theta, is the second term over the first term is this. So the common ratio, we can say the r is 3 tan square theta. Okay, so for sum to infinity, we can say -1 is less than r is less than 1. So let me solve for theta. So dividing all the sides by 3, these are cancelled out. -1 by 3 is less than tangent square theta is less than 1 by 3. All right, now we have to take a square root to get rid of this square. All the sides are squared. Here you will get a complex solution, but we are dealing with the reals only in O levels. Okay, now we are left with tan theta, the square and the square root is cancelled out, is less than 1 over square root of 3. So what is the value of theta? Theta is less than tangent inverse of 1 over square root of 3. All right. So this is in terms of pi in radians. It means my calculator is in radians. Tangent inverse of 1 divided square root of 3 is pi by 6. Theta is less than pi by 6. And the value is between 0 and pi by 2. We have to find the values of theta, not just one value. So we can say that the values of theta is 0 is less than theta is less than pi by 6. Why I'm including 0? Because in the domain we have between 0 to pi by 2. So the value of theta, my theta value is between 0 and pi by 6. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.